Let's get started with this. Okay, so let's get started then. May, June 2023, paper 5.1 and paper 5.3. We're doing difficult questions from these two papers today. Please let me know in the polls the questions that you would want me to do. So I have a few votes right now. Based on that, I will get started. So first of all, we're starting with June 23, paper 5.1. This is the first paper that we're starting with. Then we would have a look at the next paper after this. So from this paper, first of all, we've got question number 4. Question number 1 is this linear transformation or coded data. That's straightforward if you know how to do it. This one, nobody has a problem with this. Looks like a relatively easier permutation combination person. Okay. Find the number of different arrangements in this word. Number of arrangements of this. First is one, the last is n. Probability that all three O's are together, given that the two C's are next to each other. No one has a problem with this? Question number 3, part C. Was everyone able to do this? Question number 3, part C. Dashes and stars in this. But in this case, we've got conditional probability. Conditional probability, given that. That's the complication here. We have conditional probability that they're asking about, and not just simple probability. So if you know how to work with that, then yes, the rest might not be as complicated. But let's at least look at this part from this question, and then we move on to the next one after this. So this is question number 3 from this paper. The first two parts are relatively easier. Let's look at the last one. You've got this word. We want to find the probability that a randomly chosen arrangement of 3 letters, of 8 letters in this word has all 3 O's together, given that the 2 C's are next to each other. Now, what is the formula for this going to look like? It's conditional probability, right? It's conditional probability. You're given something like this. The formula is going to look like this. Remember, conditional probability formula is probability of A given B equals probability of A intersection B divided by probability of B. So what the given event is going to be the denominator. So in the denominator, we would have what is given. Probability that the C's are together. Probability that the C's are together. That's what the denominator is going to be. And the numerator, in the numerator, we would have probability that the C's are together. We're talking about intersection, right? Intersection. So intersection of what? The O's are together. And the C's are together. Both of these conditions have to be met for the numerator probability, right? Numerator is when both conditions are met. Denominator is when the given condition is met. So we have to find these two things. What's the probability that the 2 C's are together, first of all? Can we find that somehow? Probability that 2 C's are together. What would that be? There are 8 letters in total. We can think of it like this using this boxes notation. We want that the C's are next to each other. So we've got 8 boxes initially. There are 2 C's. We can merge them into 1 box. So initially, we can say we've got 8 boxes for those 8 letters, like this. But then since we want the 2's together, the C's together, we merge them in a single box. And then in the remaining boxes, what are we left with? The remaining letters. There are 6 letters. In how many ways can we arrange those 6 letters? In how many ways can we arrange these 7 boxes? These 7 boxes can be arranged in 7 factorial ways. But then, how many of these boxes are identical? You have O, O, O in some of them, and then you have N, E, and D. 3 of these boxes are identical. So we divide by 3 factorial because of that, because of those 3 O's being identical, right? And that's it. The arrangement for C does not matter because they are identical to each other, so we don't have to arrange them. They will remain as it is. Okay, that's what your denominator is going to be. That's what your denominator is going to be in this fraction. Now, it's not the probability, but it's the number of possible outcomes that we have in the denominator, right? We'll do the same thing for the numerator as well. Let's find the number of possible outcomes for this. When O's are together and the C's are together, what would that be? Let's see what that would be. When the O's are together and the C's are together. Okay. So now what we say is, let's put C's in a single box and let's put O's in a single box. There are 3 of them. So we put O's in a single box as well. And now in the remaining boxes, we've got NED. How many boxes do we have now? 5 boxes. All of them are different. 5 factorial for that. But then arrangement of C's, arrangement of O's, that does not matter. That does not matter. Right? So that's just 5 factorial. Even if we were to consider them, we could say for C's, we've got 2 factorial, but then both of them are identical. We divide by 2 factorial. O's are 3 factorial, but then all of them are identical. We divide by 3 factorial. So it doesn't matter. It doesn't matter if we do this or not. We can just leave it and we say this is 5 factorial. So what's your numerator going to be? In that probability, the numerator is going to be when both conditions are met. That's 5 factorial. And denominator, when the C's are together, that's 7 factorial over 3 factorial. That's what the denominator is. And you can see what this turns out to be. That's 5 factorial divided by 7 factorial divided by 3 factorial in the denominator. And that gives us the result. The probability turns out to be 1/7. That's what we were looking for. Is that okay? Any issues with this? No problems. Okay, let's move on. Okay, since we don't have a lot of votes for the remaining questions, the next major question that you guys have from this paper is question number 6. We'll have a look at that. For the ones that have less votes, I would appreciate that you let me know the specific parts that you want to ask about. Okay, so we won't do those whole questions, just the specific part that you're confused about. So for question number 4, which part? Part B. Okay, all right. Let's look at the next one now. Question number 4, part B. Okay, so first part, you did not find difficult. You just find the probability of this. That's simple normal distribution. And then You have a sample of 250 students. You have to find the expected value, whatever the probability turns out to be, you multiply that by 250. So the first part, you're saying you're fine with that. Let's look at the second part. Okay. So what was the question? There was a mathematical puzzle that was given to a large number of students. The times taken were normally distributed. Okay. Now in the second part, it's a different puzzle. It's a different puzzle in the second part. It's not related to the first one. It's not related to the first one. Okay. All the students are given a second puzzle to complete. Their times in minutes are normally distributed with mean mu and standard deviation sigma. All right. It's found that 20% of the students have times less than 14.5 minutes. So the probability, so if we represent times by x, we can say the probability of the time being less than 14.5, what would that be? That would be 0.2. 20%, that's 0.2. Okay. Probability of the time being greater than 18.5, what's that? That's 0.67. So x being greater than 18.5, that probability is 0.67. Now, given this, we need to find the value of mu and the value of sigma. How do we do this? This is inverse normal. We have the probability given. And we have to find some missing information in the data. So that's inverse normal, right? First of all, we write it in this form. We say this is probability of z less than this. That equals 0.2. Now, if this number is positive or negative, that's what you have to figure out first of all. How do you do that? You make a normal distribution curve. This is what it looks like. And we figure out whether this number is first of all going to be positive or negative. How do you figure that out? If the number is positive or negative? The inequality sign is the less than sign. So we are basically saying the area to the left of this number is smaller than 0.5. This area is smaller, right? 0.2 is less than 0.5. So the area is smaller. On the left side, we should have smaller area. Where do we place this number? If we place that here on the left side, we would have larger area. That's not what we want. We want the area on the left side to be smaller. So we place that here. That means this number is actually supposed to be a negative number. Okay? It's supposed to be a negative number. And we are given that this area on the left side, how much is that? This is 0.2. Now, is this the standard form that we can use the table for? No. For using the table, we need this form, z less than a positive number. It's not that form. Okay? It's z less than a negative number. So that does not work. Okay? Now, how do you convert it to the standard form? If this area is 0.2, then the corresponding positive value of z here, to the right of that value, this area is also going to be 0.2. If this is 0.2, then what's the area to the left of this positive value? This whole area is 0.8. So we could say probability of z being less than the positive value of z, that is equal to 0.8. And now this is something that we can use the table for. This is the standard form. We go to the table, find the z value corresponding to a probability of 0.8. Let's do that. Let's go to the table. 0.8 is the probability that we've got. 0.8. So we have to look for probability, right? 0.8 probability, that's 0.8000. Where would that be? We've got these two consecutive numbers between which 0.8 lies. We take the smaller of those numbers, 0.7995. Corresponding to this, we've got 0.8. We have 4 here. And then we have to add 5 more to that to get to 0.8. What's the z value going to be? The z value becomes 0.842. Right? Let's go back there. 0.842. That's the positive z value. But we know that actually z was supposed to be a negative number. So what's the actual z value then? The actual z value is minus 0.842. We have to write that as a negative number now. In the formula, we would put the negative number. What's the formula? The formula is z equals x minus mu over sigma. So minus 0.842, that equals x. In place of that is 14.5 minus mu divided by sigma. That's one equation that we've got. Okay, that's one equation that we were looking for. Then what about the other one? Again, we write this in z form as well. It becomes z greater than something. That equals 0.67. Okay, please ignore anyone who says that the paper is leaked. It's normally not leaked so many days before. It normally happens the night before that. If it happens, it has already happened twice. So anything is possible, yes. But we have to do what is in our control. I keep saying that. So make sure that you're still studying. Do not get distracted by everyone telling you that the paper is leaked. There's no point of studying. No, you should do your best. This time is not going to be wasted. As in, if you're studying, eventually, if there ends up being a retake at some point, hopefully not October, November, but earlier, then it still helps you in some way, right? You will have done some practice already. So don't listen to anyone who's saying the paper is leaked already, so don't study. They're just trying to reduce the threshold, even if it doesn't get leaked. So focus on your own preparation and ignore these rumors. What about this now? Again, we think of the normal distribution curve. It looks something like this. And we have to think about whether this number is positive or negative. How do you do that? The area to the right of this value, we know that this area is bigger. It's a larger area. If that's a bigger area, where do we place z? If we place that here, area on the right side would be smaller. That's not what we want. If you place z here, then the area on the right side is going to be bigger. So that means z here in this case as well is a negative number. So this is a negative number. Now keep that in mind. We are given that this whole area is what? This whole area is 0.67. Now, how do we convert it to standard form? If this is 0.67, we could say, if we were to consider the positive value of z, the corresponding positive value for this negative value, that will be somewhere here. The area to the left of that would also be the same. The area to the left of this positive value, this whole area, that is also going to be the same, because when you flip this figure, you get that area, that's 0.67, right? So we could write this as probability of z less than the positive value of z, that is equal to 0.67. Go to the table again, find the z value corresponding to this, and see what that turns out to be. 0.67 is the probability. 0.67 is the probability. Let's look for that now. 0.6700. Where is that? 6700. We've got exact number here. That's going to be 0.4 and 4. The z value for this is 0.44. Now let's go back there. This is 0.44, but we know the actual z value was supposed to be negative. So this is minus 0.44. The equation becomes minus 0.44 equals 18.5 minus the mean divided by standard deviation. You've got these two equations, you solve them simultaneously, and you get the result from that. Okay, you can solve them simultaneously now. You can multiply this on the other side, minus 0.842 sigma, that equals 14.5 minus the mean. Mu equals 14.5 minus 0.842 times b. You have to show this working. You cannot write down the answer directly. That's not acceptable. Minus 0.44 times sigma, that equals 18.5 minus the mean. And from this equation, you get mu equal to 18.5 plus 0.44 sigma. Okay, there's something wrong that I've done here. This was mu, so it should have been sigma on the other side. And it makes sense now, does it? There's a problem with the signs as well. When that goes to the other side, it becomes plus. Yeah, these are the two equations that we've got. Now, 14.5, that 14.5 plus 0.842 sigma, that equals 18.5 plus 0.44 sigma. Find the value of sigma for that. You can see what that turns out to be. Put that back in any one of those two equations. You'll find the corresponding value for mu as well. 14.5 plus 0.842 times sigma, and that will give you the corresponding value for mu as well. What do we get from this? Yes, tomorrow's papers are cancelled. In Punjab, all papers are cancelled for tomorrow. Only in Punjab and the rest of Pakistan, the papers are going ahead as scheduled, at least for now. But in Punjab, tomorrow's papers are cancelled. I hope the situation settles until next week, hopefully, inshallah, after Cambridge. Karachi as well? Mustafa, are you saying why are they not cancelled in Karachi? Okay, yeah, so they're not cancelled anywhere else, only in Punjab for now, okay? Only in Punjab. Okay, so mu is 22.9. And sigma you're saying is 9.95. Okay. You should use a more accurate value for sigma in this working so that the final answer turns out to be accurate. I'm assuming you've done that. Ideally use the calculator value directly. And you get the value of mu from that. That's 22.9. And that's your final answer. We've got mu and sigma. Any issues with this? Any problems with this? No? Let's not pray for exams getting cancelled. Let's actually pray for situation to get better, for everyone to be safe. And that's, I think, more important at this point than your exams getting cancelled. So please make good duas, not wish for exams getting cancelled and people dying. All right, so that's it. Let's look at the next one now. What's the next one? Okay, so from this paper, now question number 5, you're fine with that. Question number 6. Okay, let's have a look at this next. Ellie, or whatever that name is, has four-sided dice with side labeled 1, 2, 3, 4. He throws all fair dice at the same time. The random variable x denotes the number of 2s obtained. Show that probability of x being equal to 3 is equal to 3 over 64. Okay, so there are 4 dice that are thrown. Now, if you were to draw a tree diagram for that, that will become too big, right? 1, 2, 3, 4. So we'll have four branches here, and then with each one of them we have 4. That's 16, and then we have 4 more. That becomes 64 branches eventually. That's a lot of branches, right? So how do we think about this? They're talking about the number of 2s obtained. We can think of it as a binomial distribution, right? Because can we think of it as that? Yeah, we can think of it as a binomial distribution. We could say we've got something happening thrice. We've got something happening 3 times, right? If we say obtaining a 2 is the criteria for success, what's the probability of success? 1 over 4, that's 0.25. Probability of failure, that's going to be 3 over 4, right? And n is equal to 3 because we're throwing 3 dice. So we could think of it as binomial. All the conditions are met. Something is repeating. We've got 3 dice being thrown. Number 2, are the probabilities independent? Yes, the probabilities remain constant. For every dice, the probability of getting 2 is constant. We've got 2 outcomes. We can classify it as 2 outcomes. You get a 2 or you don't get a 2, right? So this can be thought of as a binomial distribution with these parameters n3 p1 over 4. We want the probability of getting 3 successes. What's the formula for that? NCR, p raised to power r, q raised to power n minus r, just input values in that. 3, n is 3. So you can say that's 3C3 into, you can actually do it directly as well in the first part. If you want all 2s, that will just be 1 over 2 into 1 over 2, 1 over 4 into 1 over 4 into 1 over 4 times 3 because of that. Mostly think about this. We want 3 successes. Could be sorry. So I was reading the question wrong. I'm sorry about that. I was just thinking why it's not giving us the final result, because it's 4 fair-sided dice. It's not 3. It's 4 dice. So with 4 dice, that becomes 4 raised to power 4. A very big tree diagram. We don't want to do that. N is equal to 4 here, not 3. We want the probability of x equals 3. N is 4, so that's 4C3 into 1 over 4 raised to power 3 into 3 over 4 raised to power 1, and that's going to give us the result. You can see what that is. 4C3 is 4 into 3 over 4 raised to power 4, and that simplifies to 3 over 64. You'll just put this in a calculator directly. Don't show the step. And that will give you 3 over 64. All right. That's the first part. Now we know it's a binomial distribution. We can easily complete this table. X equals 1. What would that be? That would be 4C1 into P, which was 1 over 4 raised to power 1 into 3 over 4 raised to power 3. Probability of X equals 2. That's 4C2 into 1 over 4 raised to power 2 into 3 over 4 raised to power 2. And you can see what that turns out to be for both of them. What do you get for this? Anyone? What's the result that you get from this? We just need to take out 1. It's safer to do both. It's safer to do both so that you can confirm your answer then. Do both of them separately and then add them up together to confirm that your answers are correct. If the total turns out to be 1, that very likely means that your probabilities are correct. So you're saying it's 27 over 64 and 27 over 1 to 8. Thank you. And now you can confirm this calculation by adding up all of these numbers. If they add up to 1, that means your working is correct. Okay. All right, let's move on. It says find the expected value of x. That's fairly straightforward again. Expected value of x, that's, since it's a binomial distribution, we can do it directly. We can use the table for this as well. Find sigma xp, that's one idea. But since we know it's a binomial distribution, we don't have to do that. We can do it directly as well. We know for a binomial distribution, expected value is given by n times p. That will give us the answer quicker. N is 4, p is 1 over 4, and that's just 1. All right? And that's your final answer. You could use sigma xp as well. That will give you the same result eventually. That will also be 1, but it's not required. Since you know it's binomial, you could do it directly like this. Is that okay? Let's move on. It says, he now throws 4 dice at the same time on 96 occasions. Okay, so he's throwing 4 dice again and again. Use an approximation to find the probability that he obtains at least 2 2s on fewer than 20 of these occasions. At least 2 2s. Obtains at least 2 2s on fewer than 20 of these occasions. It's an approximation question. What does that mean? The original distribution is binomial. We can say this is the criteria for success, that he obtains at least 2 2s when he throws 4 dice. Can we find this probability? We can say it's a binomial distribution. First of all, how many times is this repeating? 96 times. He's doing the same thing again and again, 96 times. Probability of success. Success is defined as obtaining at least 2 2s when he throws the 4 dice once. At least 2 2s. We've got the table here. At least 2 2s means you would have 2 2s, 3 2s, and 4 2s. Add up these probabilities, these three, and that will be the probability of success for that next part, right? So we say it's going to be 27 over 64 plus 27 over 128. No, 27 over 128 plus 3 over 64 plus 1 over 256. What do you get from this? What do you get from this? Sum of these numbers? $67 over 256. This is 67 over 256. And the probability of failure then, that will just be 1 minus that. And that turns out to be 189. Is that 189? 189 divided by 256. That's the probability of failure that we got. Okay. Now we have to convert it to normal. The probability that we were looking for in that binomial distribution was probability of getting this on fewer than 20 of these occasions. So probability that X is less than 20. Okay, that's the probability that we wanted to find out. Now, when you convert it to normal, we have to find the mean of the distribution. Mean is given by n times p, so that's 96 times p. That is 67 over 256. What do we get from this? What's this number? $25.125. Okay, thank you. 25.125. Standard deviation, NPQ square root, that will be 96 into 67 over 256 into 189 over 256. And then square root of that whole thing. And that will give you something. You can see what that is. What's this value? 4.306. Minimum 4 significant figures. 4.306. Okay. Now, what's the probability that we would have to find in normal? If this is the probability in binomial, we can think of 3 numbers like this: 19, 20, 21. Is 19 included? Yes. Is 20 included? No. 21? No. So we have to choose the midpoint of 19 and 20. This would be X less than 19.5. This is the probability that we now need to find out. How do you do that? Convert it to Z. First of all, you say this is Z less than 19.5 minus the mean, which is 25.125 divided by sigma, which is 4.306. And that will give you some Z value. That's going to be a negative Z value. You can see what that is. Tell me to do this. You think of the normal distribution curve after this. Since it's not the standard form. It's not the standard form. So we have to convert it to standard forms. First of all, it's area to the left of a negative value that we want to find out. So we want to find out this area. Okay, what's that z value? Negative 1.306. Okay, all right. So this is the z value that we're getting. This is minus 1.306. How do you find this area? We can say, let's flip this first of all. That's the same thing as this area. So we can say that's z greater than 1.306. That will be the same area to the right of 1.306. But again, this is also not the standard form. We cannot find this from the table. Subtract from 1 the area to the left of this. That will be 1 minus probability of z less than 1.306. Now, this is the standard form that we can use the table for. Z less than a positive number, go to the table, find the probability value corresponding to 1.306. Let's do that. 1.306, we've got 1.3 here, 0 here, and 6 here. 9032, 0.9032, and then 10, that's 9042. Let's go back. 9042, 1 minus that, and that will give you the probability that we were looking for. What's this number? 0.0958. That's your final answer. Okay. So once you find that probability of success, after that, it's just a standard approximation question. That's how you would approach that. Any questions on this, anyone? Any problems? No problems? Okay, so what about question number 7? What about question number 7? Can you specify the parts that you have a problem in? Question number 7. Can you be specific? Which part of question number 7? Or do we skip that? Okay, let's actually do this. It looks like a good question. Okay, let's actually do this as well, and then move on to the next paper after this. A children's wildlife magazine is published every Monday. For the next 12 weeks, it will include a model animal as a free gift. There are 5 different models, so it's published every Monday. And for the next 12 weeks, it will include a model animal as a free gift. There are 5 different models. These are the 5 different models, each with the same probability of being included in the magazine. Sahim buys 1 copy of the magazine every Monday. Find the probability that the first time the free gift is an elephant is before the 6th Monday. Okay, so first time something happens, does that remind you of something? We're talking about first success. What's the criteria for success here? What's the criteria for success? Getting an elephant as a gift, right? There are 5 animals that we've got. Probability of getting an elephant, that's just 0.2. So we can say it's a geometric distribution because we're talking about first success. It's a geometric distribution with probability of success equal to 0.2. Then the probability of failure, that would be 0.8. We want that the first time that the free gift is an elephant is before the 6th Monday. Before the 6th Monday. What does that mean? Probability of x less than 6. That is what we are looking for. Now you either find probability of x 1, 2, 3, 4, 5, and then add them up together, or use the inequality formula for geometric distribution. You've got the inequality formula as well. X greater than r is equal to q raised to power r. This is less than sign, so we'll have to do 1 minus something in this case. 1 minus what? Let's write down the numbers. Less than 6 means we want 1, 2, 3, 4, 5. What we don't want is 6, 7, 8, and so on. How would you describe these numbers in greater than form? The ones that you don't want. These are numbers that are greater than 5. These are the numbers that we do not want. So we can say it's 1 minus probability of x greater than 5, and that becomes 1 minus q raised to power 5, 1 minus 0.8 raised to power 5, and that should give you the result. You can see what that turns out to be. Yeah, so what do we get from this? 0.672. That's the final answer that we've got. That's it. All right, that's part A. Now it says find the probability that he'll get more than 2 leopards in the 12 magazines. More than 2 leopards. More than 2 successes. We're talking about number of successes now. What distribution is that? That's binomial distribution now. Number of successes. More than 2 leopards. What's the probability of getting a leopard? That is 0.2 as well, 1 over 5. Total number of times is 12. Probability of success is 0.2. Probability of failure is 0.8. We want more than 2 successes, so x greater than 2. That means 3, 4, 5, 6, 7, and 9, 10, 11, 12. That's too many probabilities to calculate. For binomial, we don't have a direct inequality formula. We can flip this. We can say x greater than 2 is the same thing as saying 1 minus probability of x less than or equal to 2. So 1 minus probability of x equals 0, x equals 1, and x equals 2. In binomial distribution, we also have to consider x equal to 0 case. And now we just input values in the formula. 1 minus 12c0 into 0.2 raised to power 0 into 0.8 raised to power 12 minus 12c1 into 0.2 raised to power 1 into 0.8 raised to power 11 minus 12c2 into 0.2 raised to power 2 into 0.8 raised to power 10. And that is going to give it the result. You can see what that is. What do you get from this? Zero 0.442, that's our final solution. That is what we were looking for. Okay. All right, good. Then the next part says find the probability that after 5 weeks, Sahim has exactly one of each animal. Okay, so he wants exactly one of each animal after 5 weeks. So whatever those 5 animals are, TLRE, let's write them down. TLRE and T. These are the 5 animals. All of them have equal probabilities. We want the probability that after 5 weeks, he has exactly one of each animal. So we want all 5 of these. Now, what's the probability of them coming in this order? That the first, this is one possible case, right? That for the 5 animals to be all different, right? This is one possible case. TLREB. What's the probability of this particular case? Probability of getting a tiger, that's 0.2. Probability of getting a leopard, that is 0.2. 0.2 again, 0.2 again, 0.2 again. We just multiply all of these. Okay. But then, can they just come in this one order? It's also possible that the first one was a leopard, the second one was a rhino, the third one was a buffalo, then an elephant, and then a tiger. Right? You could have some other order as well. How many different orders like this are possible? How many different arrangements are possible for these 5 animals? 5 factorial, right? There are 5 factorial different ways in which we could get these animals like this in this order. So what we do is we multiply this by 5 factorial because they can come in 5 factorial different orders like this. So if you think of a tree diagram, one path in the tree diagram would be the first is a T, then L, then R, then E, and then B. There'll be another path. For example, you might have L first, and then maybe B, and then E, and then T, and then whatever is left, R, right? So how many paths like this are possible on that big tree diagram, 5 raised to power 5? We can't draw that tree diagram, but just think of it that way. On the tree diagram, there will be 5 factorial different paths that you can follow. So you multiply this by 5 factorial, and that will give the result. You can see what that is. What's this number? 0.0384, and that's our final answer. This is what we were looking for. All right. Any problems with this? Any questions, anyone? No problems? Okay, good. So now we're going to move on to the next paper. There are a few questions from that next paper as well that we wanted to do. So questions 2 and 6 primarily, right? These are the 2 questions that you're asking about. Let's have a look at those questions now from the second paper. Just a reminder, we have our S1 classes every day now, every weekday. On this Saturday, we have the S1 workshop as well. I posted about that in the WhatsApp group already, I think. I will leave a reminder there as well. It's going. You don't have to register for that separately. People who are registered in the past paper sessions, you don't have to register for that separately. You will be added to that group automatically. Okay. So those of you who are part of the past paper sessions, you don't have to register for that separately. So don't do that. I will just send a reminder about that and also add you all to that group. This weekend, we have that workshop from around 4 p.m. to 10:30 p.m. inshallah. Okay. But share that with others and your friends and circle. That would be helpful. Let's move on to the next one now. So our plan for tomorrow is, I think, let me look at that list again. Yeah, so plan for tomorrow is that we do June 23 paper 5-2. And then on Saturday, we have that revision workshop. It's going to be a long session, so be prepared for that. We'll have breaks in the middle so that you can digest the concepts. But it's going to be like a very long session, so you should be prepared for that. Let's look at the other paper now. Five, 3. Okay, so June 23, paper 5-3. From this paper, you are mainly asking about questions. I forgot again. Let me have a look at that again. Questions 2 and 6. Okay. All right. Let's get started with this one now. Questions 2 and 6. Okay. What about this now? 2 fair coins are thrown at the same time repeatedly. Okay, so we don't have to do this. That's not what you asked about. The first question is really straightforward. It's just geometric, first of all. And then in the last part, you've got geometric as well. So this whole question is geometric. Okay, question number 2 is the first one that you're asking about. That is not like that difficult. It's a standard approximation question. Okay, let's have a look at this. Anil is a candidate in an election. He received 40% of the votes. A random sample of 120 voters is chosen using approximation to find the probability that of the 120 voters, between 36 and 54 inclusive voted for Anil. Now, this 40% is the total votes that he got, right? 40% votes. So if you were to randomly select a person, what would be the probability? What would be the probability that they voted for Anil? That would be 0.4, right? So they want us to use an approximation to find the probability that out of 120 voters randomly selected, this many voted for Anil. Now, first of all, we know original distribution is going to be binomial in this case because they're talking about approximation, and we have to convert that to normal. What's n? 120. We're talking about 120 people, so it's repeating 120 times. Probability of success, probability of someone voting for Anil, that's 0.4. Probability of failure, that's 0.6. And the probability that you want to find out, for those 120 voters, what's the probability that we got between 36 and 54 successes, right? We want this probability. But inclusive means that we have an equal to sign with 36 and also with 54. Both of them are inclusive. Okay? That's the probability that you want to find out. First of all, we convert it to normal distribution. How do you do that? Find the mean, n times p, that will be 120 times 0.4. What do we get from that? 120 into 0.4? 48. And then sigma, what would that be? 120 into 0.4 into 0.6, and then square root of that. You can see what that turns out to be. What's this value? 28.8. Square root of 28.8. Right? That's what the standard deviation is. Convert this to normal. Convert this to normal and see what that gives us. X is between 36 and 54, right? How do you convert? How do you do continuity correction here now? Write down these numbers: 35, 36, 37. With 54 as well, you've got three numbers that you have to consider: 53, 54, and 55. Okay, now think about this. Is 35 included? Is 35 included? Is 35 in this interval? It's not. 36? Yes. 37? Yes. This is where the decision is changing. Between 35 and 36, so we would have 35.5 here. On the other side, is 53 included? Yes. 54? Yes. 55? No. This is where the decision is changing. So we have 54.5 here. This is the probability that you want to find out in normal distribution now. And now we do it like we normally do it for normal distribution, convert it to Z first of all. So it becomes Z between 35.5 minus the mean value. What was the mean value? Mean was 48 minus 48 divided by sigma, that is square root of 28.8. And 54.5 minus 48 divided by square root of 28.8. You can see what these values turns out to be. And then think of the normal distribution curve to figure out how to find that area. What do we do now? What do we get from this? Anyone? Z values. They should be written correct to 3 decimal places. What are you getting? Okay. Minus 2.329 and 1.211. Okay, good. 1.211. These are the two values of Z that we're getting. Now, how do you find this area? That's the question. Think of the normal distribution curve. Think of the normal distribution curve and figure out how you can find this area. Let's say this is the normal distribution curve that we've got. We would have mean in the middle. That's 0. Minus 2.329, that's on the left side, minus 2.329. And 1.211, that's on the right side, 1.211. We are interested in this area. We're interested in this area between these two numbers, right? That's what you want to find out. How can we find this area now? How do you think about this? You could start like this. You could say it's the area to the left of 1.211 minus the area to the left of minus 2.329. Let's start like that. We can say this can be broken down into two parts like this, first of all, as Z less than 1.211, area to the left side of 1.211, subtract from that area to the left side of this number. So this whole area minus the small area, that will leave you with the yellow shaded area. Okay, now this is the standard form. You can find this area directly from the table. There's nothing that you need to do with this. It's Z less than a positive number. You can use the table for this. However, this is not the standard form. So we have to think about this now. What about this other probability now? We can again think of the normal distribution curve. The area that we're looking for is this small area, minus 2.329. This is the area that we want, area on the left side here. How do you find that? You can flip this first of all. You can say that area is the same thing as this area, right? So you could replace that with, first of all, you could replace that with Z greater than 2.329, right? To the right of this value, that will also be the same area. Make sense? But again, this is also not the standard form. We can say subtract from 1 the area to the left of this number. That will be 1 minus probability of Z less than 2.329. This is what we have to subtract from Z less than 1.211. Now just go to the table, find the probability for each one of them. 1.211, what's the corresponding value of probability that we get for this? 1.211, let's go to the table. 1.211. 1.2, 1, and 1. We get this number here. Go on the right side. We get 2 here. 8869 plus 2 at the end. It becomes 8871, right? 8871. 8871 minus 1 minus probability value corresponding to this Z value. 2.329. 2.3. And then 2. That's this number here. And then 9. That's 2 eventually. 9898. And then you add 2 to that. You can write that on the side. 9898. Add 2 at the end. What does that become? 0.9900. That's what you write there now. This is 0.9900. Evaluate this, and that's the probability that you're looking for. You can see what that turns out to be. What's the result that we get from this? 0.877. 0.8771. You can round that up to 3 significant figures. That's 0.871. And that's your final answer. That is what we were looking for. Is that okay? Any problems with this? Okay, good. Let's move on. Let's move on to the next one now. Okay, so no other problems from this? No other problems from this paper? So there was one word on some other question, I think. But now that's also gone. All right, so let's go through the paper quickly. You've got this probability formula given. You just input that there and find those probabilities, make a table, variance, stem and leaf. Okay, some of the numbers is less than 6, whether they're independent or not. Okay, we might come back to this. This is normal distribution. We've done so many of those already. Two C's are not together. Exactly 3 letters between the two C's. 5 letters at least 2 A's. In this we have to find the number of selections. You guys don't have any problems with any other questions? Are you sure about it? No problems in any other questions? Sure? Okay, good. So that's it then. We will stop here then. And I will see you again in the next session. Tomorrow we will be completing one full paper, and that paper will be June 23, paper 5-3. So paper 5-2, inshallah. Okay, that's what we do tomorrow. And then on Saturday, we've got the S1 workshop from 4 p.m. onward, the revision workshop. All right. Okay. Thank you, everyone. Take care. Allah Hafiz. Thank you. Stay safe, everyone. I hope things stay fine with all of us, everywhere in Pakistan, and hopefully with the civilians in India as well, not the army. Let's pray that we have a good outcome out of all of that. Everything settles down, inshallah. Make du'as, make a lot of du'as for your exams, of course, but also about your country, about the whole Muslim population in the world, that things get better for us, inshallah. All right. Allah Hafiz.